Hello, my name is Chris Malcolm Lynsung, and I am a student under Dr. Hartman in the Tracing the Raritan Interdisciplinary Seminar. For my final project, I decided to focus on the impact of dams and dam removals on our waterways. I present to you dams. What is a dam? Dams, both natural and man-made, serve as a form of hydromodification. They are used to store water and to generate electricity. Throughout this presentation, I'm going to be focusing on human-made dams, but I did want to show a beaver-made dam here, as they are the original creators of dams. Why do we build dams? Dams are built for many reasons, but the main ones are because they are currently our best form of hydromodification. They generate hydropower and electricity, they create drinking water reservoirs, and it can be of economic benefit to those in the business of dam building. Before modern hydroelectric dams were invented, water wheels were used to generate power, usually utilized to power mill houses. There are four types of water wheels: undershot, breastshot, overshot, and pitchback. The pitchback is set up very similarly to the overshot, only the water source is located on the opposite side. The pitchback is actually commonly paired with the breastshot in order to increase the amount of power generated. Mills were used as early as the 2nd century BC, but have become essentially obsolete in developed countries due to the availability of cheap electrical energy by the early 20th century. However, they are still used in some developing countries. There are many kinds of mills, since the hydropower can be utilized for lots of varied tasks, anything from sharpening blades to weaving cloth. Here you can see how mills convert the movement of water, utilizing any of the aforementioned systems, into motor power to grind. I wanted to show a visual of a mill's water wheel in action, and I found that this GIF of a water wheel from the popular video game Skyrim was a lot clearer and more aesthetically pleasing than any other examples I found. How are dams built? Modern hydroelectric dams are built on soil or rock foundations, which are lower than the original ground level. The foundation has to be strong enough to handle both the weight of the dam and the water pressure that will act on it. For concrete dams, they can be molded before placement or poured and compacted with rollers. Embankment dams, also known as earthen dams, are built up in layers of various compositions of soil, sand, clay, or rock, using the most impervious materials to form a core and placing more permeable substances on the upstream and downstream sides. Once the dam is completed, a protective waterproof layer is added to its upstream face. This layer is added to both concrete and earthen dams. Here you can see how dams work to generate power. Dams, like mills, utilize the movement of water. Dams use this movement to power a generator and produce electricity, as opposed to mills, which use this movement to move internal structures and complete varied tasks. Dams are built as a benefit to human life via hydropower and water storage, but they do cause detrimental effects to the waterways they are built in. Two of these images show how dams lead to a buildup of sediment on one side of the dam. So, along with little to no water flowing from one side of the dam to the other, there can be a huge decrease in sediment flow downstream. And, in the case of coastal wetlands, this is especially detrimental because the coastal wetlands don't get the sediment needed to keep increasing coastal elevation. Along with sediment buildup, dams create reservoirs, which displace communities in the water, increases waterborne illnesses, and triggers earthquakes. Dams can trigger earthquakes due to the extra water pressure created in the micro cracks and fissures in the ground under and near the reservoir, as is shown in the bottom right image. And downstream of a dam suffers from a decrease in biodiversity, as well as poor water quality, which can lead to poor crop production during droughts and decreased fish populations. There are still many dams present in the lower Raritan watershed, but there are programs like the Natural Resource Damage Assessment and Restoration Program in place to remove all of the ones that wouldn't detrimentally impact power or water supply systems. In this presentation, I'm focusing on two recent dam removals, one from 2017 and one from 2019. In 2017, the Weston Mill Dam on Millstone River between the Borough and Franklin Township was removed. The original dam at Weston Mill was built around 1844, and the modified concrete dam at the same location was built in the mid-1930s. The dam removal was funded and driven by partners such as the National Oceanic Administration, the U.S. Fish and Wildlife Service, and the Stony Brook Millstone Watershed Association, with shared conservation goals through the Natural Resource Damage Assessment and Restoration Program, because it would benefit water quality, fish, and recreational opportunities for local communities. Other partners in the Raritan Basin effort included American Rivers, Conservation Resources Incorporated, the Geraldine R. Dodge Foundation, the Horizon Foundation, and the Raritan River Fish Passage Initiative. The removal of the Weston Mill Dam, also known as the Weston Causeway Dam, was the latest in a series of dam removal projects undertaken by state, federal, nonprofit, and private partners to make waterways in the Raritan River Basin free-flowing again. Funding for the project was secured by the Department of Environmental Protection's Office of Natural Resource Restoration, the National Oceanic and Atmospheric Administration, and the U.S. Department of the Interior through a Natural Resource Damage Assessment Settlement Agreement. The second dam removal is even more recent, from this past October 2019. It was planned to be fully removed by the end of October, so it should be completely gone now. A derelict concrete dam on the Lamington River between Branchburg and Bedminster was removed to improve the flow of the Raritan River tributary. The nonprofit Raritan Headwaters Association, also known as RHA, and its partners worked together to remove this dam. A contractor was hired by RHA and began work on October 12th to remove the shallow dam at the site of a former grist mill built in the 1800s. The $250,000 project was funded by the U.S. Department of Agriculture's Natural Resources Conservation Service, also known as NRCS, the U.S. Fish and Wildlife Service, and Raritan Headwaters. The U.S. Fish and Wildlife Service also offered technical expertise in fish passage engineering, permitting, and construction. The NRCS was proud to fund a project like Burnt Mills Dam, as it will have a sizable ecological uplift to the Lamington River and build upon other NRCS-funded stream restoration projects in the Lamington River, as well as help continue the momentum of other recent dam removal and stream restoration efforts on northern New Jersey rivers. The U.S. Fish and Wildlife Service was also pleased to be a partner in restoring the natural flow of the Lamington River, since it would be improving habitat for migratory fish and imperiled mussels, and potentially reducing the risk of flooding to nearby residents. So, as you can see from both of the dam removals, you need a lot of involvement, partners, and funding in order to simply get a dam removed, but it is ultimately a great benefit to the waterways that the dams were built in. So why should we give a damn about dams? 71% of the Earth is covered in water, and 96.5% of that water makes up our oceans. Fresh water makes up under 3% of all water on Earth, and nearly 65% of this drinkable water is tied up in glaciers. Rivers, streams, lakes, and dams that hold fresh water contain 1% of potable water, while groundwater accounts for about 0.3%. We implement dams to control water flow, but we need to be more conscientious of how this affects our waterways. Removing dams is a way to help our planet and through that help ourselves. By removing dams from our waterways, we can restore water levels and shorelines for downstream crops dependent on that water. We can restore natural movement of sediment downstream to shorelines. We can reduce increased evaporation and contribution to global warming. We can reunite populations in the water that may have been separated due to the placement of the dam. We can decrease waterborne illnesses, increase water quality via more dissolved oxygen, lessen the risk of triggering an earthquake, and increase biodiversity and fish populations. And, in a more direct manner, it would reduce the risk of flooding, as well as aid with the health of those who depend on our watershed as a source of food and water. Keeping in mind that you are all my audience, I wanted to give a general background as well as highlight the aspects of dams that aren't usually touched on, things like how and why they're built, as well as real-world examples of dam removals and the positive effects of those removals on the waterways they're built in. I hope I was able to broaden your ecological literacy through this presentation. And here is a compiled list of all the sources I used. Thank you so much for your attention.